Yeah, hey everyone. So for today's topic, I kind of wanted to expand on this memory management concept we've been talking about. So as we talked about yesterday, we kind of discussed RAM, kind of its performance when compared to some sort of long-term storage, so HHD, SSD, and items of that sort, and kind of how it applies to Boomi. So today I wanted to talk about Heap. So at a high level, like we've talked about before, Java does manage its own memory, so there's no need for a programmer to allocate or deallocate memory like in a language such as C. We're not there yet in terms of how Java does that, but regardless, memory management is still needed for high performance programming and programs to run, just so you don't have problems where it might crash due to a memory leak or an out of memory condition or items of that sort. So, though Java does manage its own memory, there are situations where you can still loop too much or overflow memory or items of that sort that would cause your application or processes to crash. So, with that said, we're going to talk about Heap today. So, what is heap memory? Heap memory lives in RAM. So, we talked about RAM yesterday, and it stores the actual objects used for a program. So, in this case, it's going to store whatever you're using in your process and whatever's needed at that point in time that's going to live in the heap. So, with that said, there's only one heap memory per JVM process. So the assumption is, let's say you have your parent JVM on your node, no forking because we haven't gotten that far yet. So you have your node and you have your JVM. There's only one heap memory per that. And heap can be fixed or dynamic depending on the application and as well as the Java JVM arguments you can pass. So some people like fine tuning Boomi. So what they'll do is they'll add arguments for the maximum amount of heap and stack size. So we haven't talked about stack yet, but those are the two biggest parts of Java memory management, heap and stack. So you can fix how much it can go up to, how much it's going to start at, and items of that sort. So technically, there's no maximum heap size in Java. That's just going to be dependent on the virtual machine or the actual server that the process or the runtime environment is running on. So as much memory as you got there, you can allocate to RAM, and then in turn, heap is based off of RAM. So that's how you kind of get that. And should there be problems with heap memory, so let's say a memory leak and add a memory condition, within support, if there's nothing glaringly obvious going on, a great way to see kind of the heap memory at that point in time is a heap dump. We do have system properties within Boomi to generate a heap dump on an out of memory condition. So from there, there's ways to analyze kind of what objects were, whether they were in memory at that point in time or what kind of took up all of the heap memory. And then from there, you can kind of determine what went wrong, whether it's someone pulled a super large document and crashed a heap allocated to it, or there was a loop in a custom code or a custom connector where it never finished a loop and it just kept running and running until they ran out of heap or stack memory, or items of that sort. So that's why we always suggest, if needed, getting a heap dump and then analyzing that. There's a lot of good tools out there. Specifically, I believe Eclipse has one. There's just essentially what you would do is it generates a hprof file, and then from there you can put it in and it can show you if there's a certain object or objects consuming most of the heap memory. But if it's pretty like equivalently balanced, that usually means just your environment is undersized. And then in that aspect, you should just increase heap memory, which is possible through a property from the UI. That's what I wanted to cover today, and that's it for heap memory. Enjoy the rest of your day, guys. Bye.